So you are given system of equations, three equations and three unknown, and solve this using Gauss-Jordan elimination. What we need to do as a first step, copy down the coefficients. Step number one, element 1, 1. We want to make that 1. Okay, that's good. And let's say if I switch those two equations, then you end up getting 2, 1, 1, 3 in the first row. So simply switching those two is going to be the best option. Otherwise, you're going to divide everything by 2. That means 1, 1 over 2, 1 over 2, 3 over 2. You have to deal with these fractions throughout the problems. That's not good. And step number 2, we need to make E2, 1 element 3, 1 to be 0. So this guy and this guy using row 1. I'm going to just copy down the row 1. And to get to row 2, element 2, 1 to be 0, we need to multiply R1 times negative 2 plus R2, put it back to R2.
Negative 2, 2, negative 2, 2, the R1 times negative 2, R2, 2, 1, 1, 3, and add 0, 3, negative 1, 5.
And for the row 3, we need to do R1 times negative 3 plus R3, put it back to R3.
Negative 3, positive 3, negative 3, positive 3, 3, 2, 2, 8, add 0, 5, negative 1, and 11.
Step number 2, E2, 2, we need to make that to be 1, which is this guy. So in order to do that, we need to divide the row 2 by 3. 0, 1, negative 1 over 3, 5 over 3. And step number 4, E1, 2, E3, 2. We need to make that to be 0, these two guys. We need to use R2. So we need to use R2 times, so negative 1, so we don't have to multiply anything. R2 plus R1, put it back to R1.
0, 1, negative 1 over 3, 5 over 3, R1, 1, negative 1, 1, negative 1. We add 1, 0, 2 over 3, 2 over 3.
And for R3, so we have to do R2 times negative 5 plus R3, put it back to R3.
0, negative 5, 5 over 3, negative 25 over 3, and then R3, 0, 5, negative 1, and 11, add 0, 0. This is 2 over 3, and this is 333. So is that 8 over 3?
I'm going to copy down this row 3. I'm going to multiply R3 times 3 over 2. If I do, I'm going to have a 0, 0, 1, 4, and that is actually step number 5. E33, we want to make it to 1. That's what we did here. And then step number 6, E13, and then element 2, 3, we want to make that to all 0. So this guy and this guy. So we have R3 times negative 2 over 3, and then add R1, put it back to R1.
We have a 0, 0, negative 2 over 3, and negative 8 over 3. And R1, we have a 1, 0, 2 over 3, 2 over 3, and we add 1, 0, 0. It's a 5 over 3.
No, 6 over 3. R2, we have a negative 1/3. So we're going to multiply, R3 times 1 over 3, and then add R2, put it back to R2.
We have a 0, 0, 1 over 3, 4 over 3, and R2, 0, 1, negative 1 over 3, 5 over 3, and we add 0, 1, 0, 9 over 3.
X equals to 2, Y equals to 3, and Z equals to 4. That's the answer. Make sure you follow these steps, making the first row, first column to be 1 and all below 0, and then second row, second column to be 1, and the upper one, lower one to be 0, third row, third column to be 1, and all the above equals to 0. That's the steps you need to follow. If you don't do it, you're going to be circle around and you're not going to get this. So let's work on this problem. It's exactly the same problem, but this time we want to use inverse matrix to find the solution. We got the solution, x as a 2, y as a 3, z as 4. Let's see if we use inverse matrix, we end up getting the same answer. We should. So for using inverse matrix, first thing we want to do is to find the delta. To get the delta, we need to have the coefficients. First,
1, -1, 1, 2, 1, 1, 3, 2, 2. And we're going to copy down top 2 row, the bottom 1, -1, 1, 2, 1, 1.
And then draw the diagonal line with the 3 elements. This is the first one, this is the second one, this is the third one, and then we multiply them. 2, 4, -3. When I do that again, the opposite direction, here's a 1, here's a 2, here's a 3. This time it's gonna be negative the multiplication. 3 times 1, 3, 2, 1, 1, 2, -4.
So then delta equals to -3, -2, plus 4 for the left side of the numbers, plus 2, plus 4, -3. So 2 and 2 cancel out, and then we have 8, -6. So the delta has to be 2.
Now we need to do A transpose. So this is A. So find the A transpose.
Draw 2 columns. So 1, -1, 1, 2, 1, 1, 3, 2, 2. Copy top 2 rows. 1, 2, 3, -1, 1, 2, and 2 columns. 1, 2, -1, 1, 1, 1, 1, 2, -1, 1.
And cross out first row, first column. Now we're ready to find A inverse 1 over delta. Delta is 2.
First row, first column, we need to do this for the AD minus BC. So that is AD2 minus BC, and then these two, AD2 minus BC, and then these AD minus 1 minus BC, and then these 4, AD3 minus BC4, AD2 minus 3, AD2 minus BC1, and then the last row, AD4 minus 3, AD -3 minus 2, AD1 minus. So now we have an inverse matrix is 1 over 2. We have a 0, 4, -2, -1, -1, 1, 1, -5, 3.
Inverse matrix times B will give us the solution x, y, and z. You can multiply 1 over 2 to the inside of this matrix, then you end up getting some fractions. We can distribute this fraction 1 over 2 later. So what I'm going to do, I'm going to just keep it as a 1 over 2, and this is 3 by 3, and this is 3 by 1. Inner numbers the same, so we can multiply them, and then outer numbers 3 and 1, that's the actual dimension of the result of this multiplication. Can do 1 over 2. The result is the 3 by 1.
And then first row is going to be this times this. 0 times -1, 0, plus 4 times 3, 12, plus minus negative, the 2 times 8, 16. And then second row, this times this. So -1 times -1, 1, -1 times 3, -3, 1 times 8, plus 8. And then third row and the column, 1 times -1, -1, -5 times 3, -15, 3 times 8 is a -4, 6, and then -9, +9, 8.
So then x equals -2 y equals 3, and z equals to 4.